Welcome everyone. In this course, we are going to discuss about the Cisco SD-WAN, and we are going through all the different components which we required, and we will learn about the Cisco SD-WAN. So let's get started. So first thing is that what is before SD-WAN, what was happening? We need to understand that one. So before SD-WAN, there was a traditional setup where everything, whatever there is a branches over here, different branches, all the traffic from the branches were going towards the data center, and from the data center they were routed towards the internet or routed towards the applications which they required. But the only thing is that all the branches are now the traffic is being sent to the data center. So that's why they do in order to communicate with the data center, again they need to have a private network, that is the MPLS. Now this one is like increasing the bandwidth, means increasing of the cost. So they need a good bandwidth in order to maintain this stability in the traffic communication. So that was the issue and challenges in the traditional. So what was happening here is that when connecting to the distributed workforce, like some of them are working from home, so work from home. So whenever they are connecting, again they have to connect to the data center using the VPN. Then again from using the VPN, all the traffic has been routed towards the internet or critical applications which they need to access. So that's the reason since all the traffic is being sent to the data center over the MPLS network, so the cost and the bandwidth is always high on the MPLS. Now another thing is since this one, if you see that everything is like an hub and spoke topology, because all the traffic is being sent to the data center, no matters what. From the data center, all the traffic is being routed to internet and applications. So it's like an hub and spoke. So doesn't matter where do you want to go, you have to go via data center. So for example, work from home wants to go to and access some kind of applications which is on a remote site. Again, first it will go to the data center, and from the data center it will communicate with the application on the remote side. So basically that was the limitation in the traditional setup, where everything has to go to the data center using the VPN, the cost of the VPN, the cost of the MPLS, and the bandwidth. So that was the challenges. And now this increased the MPLS cost as we discussed, and also this increased the bandwidth. The most important was the latency. Due to this one, the accessing of the applications was not pretty good, and people used to keep on complaining, saying that the application is running slow. But in fact, it's not running slow, but because of the high bandwidth usage, it's now reduced. It is like a bottleneck. That's the reason it is been have a huge amount of latencies. Now, poor application experience, that's the reason. Because of this latency, you do have the poor application experience. So now WAN often composed of components from different vendor. Another challenge was like if you are integrating services with the different servers, now you don't know how to integrate things, which becomes complicated. Even though you integrate things from the different vendors and you manage to communicate with those vendors, integrate things and all those things, then again still you do have a problem of a complex configuration. Now, whenever there is a complex configuration, then you have a high probability of human error. Now, whenever there is a high probability of human error, that means the business will lose a loss of money. And again, not only the business will be losing the loss of money, the network will be having a less visibility, less performance, and the main thing is that to troubleshoot the problem, it will take a lot of time. So there is a lot of downtime. So which is not very good for any business. Now, what the SD-WAN is going to do is that it's going to address these problems now. So it is focused on the technology prioritize. That means the critical business traffic, advantage of internet broadband connection. That means first you have to go via only MPLS. Now you can use your internet, or you can use your 3G, 4G, or maybe the LTE or MPLS. So there are now different means of transport using the satellite also. So these are the different means of transport. Now, if the traffic is the bandwidth on the internet is high, then you can do the policy based routing, and you can say that okay, when it is with bottleneck on internet, access the application using the MPLS. And again, if both of them are like very busy, then you go with the LTE network. So now that's the benefit now SD-WAN gives you that will resolve the problem of like hub and spoke one. Now, since you do have the redundancy and all those things, now your experience with the applications will be very good. Now simplify the management of WAN fabric using the controllers first overlay and underlay. So we will discuss about this one in later, where we will discuss about what do you mean by the overlay and what do you mean by the underlay. Now let's move forward. Now evolution is that Cisco SD-WAN is like Cisco did not develop the SD-WAN. They do also have, but much efficient way they did have with the Viptela one. So Viptela is the first company which developed a flexible and efficient, you can say, the SD-WAN architecture. So again, since Cisco acquired the Viptela because they were also developing the SD-WAN in the form of a DNA, and this SD-WAN and DNA were like similar architecture. So that's the reason Cisco acquired that one, and they released the product as a Viptela. So wherever you see that any Cisco product using V Edge, so V represents the Viptela. And if you see any C Edge, C represents a Cisco. All right. So on August 2017, Cisco acquired the Viptela. Now let's understand now, as I said, that there is an you can use a multiple transport, you can access the application and all those things, how this works like. So now what happens in the traditional way is that you do have a data center and you do have a branches. So whenever they want to communicate with each other, they have to go via the data center. And now on this data center, this is the MPLS. Then again, you have to use the VPN in order to secure your traffic. But with the SD-WAN, what happens is like every component is now separate. So now the management, you can have the management anywhere. You can have it on the cloud, you can have it on the on-premises, doesn't matter. So you do have a management plane, you do have a service plane that is being differentiated. Now you do have a transport where you can use multiple transport, and you do have a location. Now, for example, how this works is like if you have your controllers on the cloud, so they are always available on the cloud. The only thing is that whenever you have the branches, they are already been connected. Now you implemented, like you provision the new site. The only thing is that you need to just connect to that controller on the internet, or using the MPLS or using the LTE. You just need to connect. Doesn't matter what kind of transport you're using. The only thing is that you need to have a reachability between your controllers and your branches. That's it. So once you have the access connection to the controllers and the edge devices, you can manage and control your services, application traffic, and visibility, each and everything from management plane. Even you can push the configuration using the management plane. So this resolves the problem, like instead of having the default setup where the new remote site has to come up, if you want to do the provisioning, then you have to do some kind of configuration, some kind of setup and all those things, and you have to set up the VPN and everything. Those things need not to be done now. The only thing need to be done is you need to have the reachability. Once they have the reachability, they will authenticate itself automatically, and they will onboard the device automatically. The only thing you need to do is that you need to just provide the IP address and the DNS server that should be resolving some FQDNs, and apart from that, you don't need anything. So once that has been resolved, it will automatically connect to those controllers and automatically get the configuration from the controllers. Now looking deep inside the SD-WAN operation, as network become most complex as organization, because as you know that organization keep on tying the data centers, remote branches, like backup branches, all the devices or all the sites now are tying up together in a distributed environment. So now you do have many branches over here because of the SD-WAN, and now you want to manage in a centralized way. So this is where the challenges the SD-WAN resolve it, because now since the configuration became easy, it will be easy for you to manage these kind of many remote branches. So now no visibility inside WAN network in traditional WAN, as we know that since we are doing the configuration, we do not have much visibility in the network WAN, what is going on, which traffic is being communicated and all those things. Now with the SD-WAN, you do have an ability to monitor, you do have the ability to measure the traffic and measure the performance and visibility. You do have the what kind of traffic is been passing through which branch is accessing most of the traffic, like for example HTTPS or application traffic. You can have that details in your control plane. Now SD-WAN, you can by default on the premises or the cloud, you can see the some of the traffic. But if you are interested, if your organization is interested in getting in depth of the monitoring of the traffic, then you can go with the V Analytics. So V Analytics is a cloud-based tool with the advanced algorithms over there, so which will help you to get more details of your traffic. So it will help you in doing the monitoring. It will help you in analyzing the SD-WAN performance via vManage portal. So you will just have a connectivity on the vManage portal. You will have the connectivity of the V Analytics, and it will automatically provide you with the options and the different algorithms where you can look deep into your traffic. Now, Analytics provides specific usage for monitoring the bandwidth usage, application performance, and detect anomalies based on application. So anomalies means it's just nothing like whenever some of the devices who are accessing, for example, you do have a remote branch, and from this remote branch you are connected where the users are connected. So every day the users are like connecting to the application. That's all good. But for some reason, every time it was supposed to be 1 GB of bandwidth, for all of a sudden today it came back at 2 GB of bandwidth. Then V Analytics will have a investigation in that one, why they are using so much of bandwidth, and it will give you an output saying that, okay, so this was the problem. This is why we have been using the 2 GB of bandwidth today. Now, an integrated and improvement in VLAN V Analytics. That means, as you know, that AI is everywhere. So they have also integrated the AI in the V Analytics. Extending support for ISR on ASR. So before they do not have any support for ISR and ASR. So as you know that ISR and ASR routers are mostly used with the ISPs. So now with the ISPs, they do have already 1 million of devices over there. So Cisco came up with saying that, okay, we will provide the support by releasing some kind of software updates. So using that software updates, they can upgrade to, or they can do the provisioning for the SD-WAN. So basically, instead of replacing all the millions of devices, what Cisco did was like just create a software for them, provide an update, and help them to transform from the traditional to the Cisco SD-WAN. Now, coming with the security, now as you know that the main thing is the security nowadays, because all the branches are connecting on the internet. Remote employees are also connecting on the internet, and the cloud applications are also able to access via internet. So now the internet is very important nowadays, because all the things you are using internet in order to connect everywhere. Now this is where the challenges is like, yes, I am accessing, all the people are accessing the internet. That's good, not a problem. But the main thing is the sensitive data. So now, since I am using the internet, my sensitive data is being passing on the internet. So I need to secure that one. So that is my now concern, because it is going outside of my branch or outside of my organization. The traffic is going to the internet. That means it is going outside of my organization, and I want to make sure that the data is secure. Now, this also increase in the risk, because if any breach happens, any leak happens, that's what it will compromise the organization. Now, what I need to do is that whenever the users are trying to access the application via internet or MPLS, doesn't matter. My main concern will be the data protection. So providing on-demand workforce. So I'm providing the security for the on-demand workforce. And of course, there will be technical challenges in order to overcome this problem. Now, Cisco already knew that this will be a problem, so they already came up with saying that, okay, whenever you go ahead with the Cisco SD-WAN, we do have certain components which you can integrate, or you can just download and install it within your vManage, that is your in your controller. So those things are like application aware firewall, which is inbuilt. Intrusion and prevention detection, you need to download and install. AMP, so this is the integration between the AMP and the Cisco SD-WAN. That's a pretty good one. So AMP is usually used for the endpoint security. So mainly you can say this is for the work from home or remote users. Now, Cisco umbrella to provide the DNS security. So if you are familiar with the Cisco product, this is what mainly Cisco umbrella is mainly used for the DNS attacks. Now, the advanced malware app is used for the endpoint, and intrusion and detection prevention, you need to download the component and install it in your controller in order to utilize that feature. Application aware firewall is just you can say just like a normal firewall, where you can utilize the benefit of creating the access rules and policies and mitigate the problems. Now, what security stack also provide is that if you have a multiple domain in a distributed in a very large domain, it is also supported. You can create the access policies, security policies. Now you can create the access policies in a centralized one, or if you want to create in a localized one, you can go ahead and create. So centralized means it will affect all the network. It will receive in perspective of connecting all your organization devices, and localization means is going to affect only the specific branch. Now, across all the data centers, campus, and IoT devices. So whenever there is a security, you want to make sure that your data centers and the components which are installed, the applications which are installed within or hosting within the data center, that should be secure. And with campus and branches, you do know that they do have a lot of IoT devices like smartphones, PCs, and their own laptops and all those things. And you want to make sure that you want to secure those devices also. Now, Cisco is enabling unified policy management in linking ACI. If you familiar with the Cisco product, again, this one is used in the data center, software defining. And SD access, this is what the Cisco has created with their own SD-WAN architecture, mainly used for campus. So now you can have this, if you have the ACI and the SD-WAN, you can go ahead and integrate with each other, and you do have a unified policy management within these two, because both of them are software defined technologies, two different ones. One is mainly used for the ACI is mainly used for the data center, SD-WAN is used for the businesses like an organization. But when you do have these two technologies working, then you can integrate these two and you can utilize to centralize management both of these technologies from one plane. Now, revolutionary result of SD-WAN. Since SD-WAN, the MPLS spending has been reduced by 25% and the bandwidth is increased by 3075. That means that instead of having all the traffic within the MPLS network, now you are only having MPLS network only for the critical based application or the applications which your organization required to be communicated over the VPN or the MPLS private network. Now, the SD-WAN also help you to monitor the traffic by using the functions. So where there are programming developers, they use a lot of functions. So you want to see that what traffic you want to categorize the traffic with respect to the function and see how much the traffic is being accessed on the function. Then you do have the option or the ability to see that one. And a different type like HTTP, HTTPS, or UDP or DNS traffic. These are the different traffics. If you want to see different type of traffic, you can monitor from the SD-WAN pane. Now, sending backup traffic. So as I said, that the policy-based routing. So one device of one branch has two different networks. So one is connected to the ISP, one is connected to the MPLS, and both of them are able to communicate to an application. So for some reason the ISP is down, then automatically what SD-WAN do is that this traffic will be shifted via communicated via MPLS. So it is automatic, but if you want to create the policy for that one, you can create the policy. Now, the main thing, most important thing is that redundancy for software updates. So before it used to take the 8 hours, now maximum time they say like 10 minutes, but we can say that it might be 15, 20 or 30 minutes also. It depends. Now replication across all the networks, since you have to do one by one in the traditional one, in the one by one branch you were supposed to do, but now all at once you can do the upgrade. So updates can be done all at once. Now, adding new internet-based services like used to take months whenever they want to integrate some new service. So first they have to plan, they have to see the how the integration will work, what are the different problems they will face, and all those things. So they have to do a lot of working before they go ahead and implement the service. So that might take months, but not now. So everything is like pretty much straightforward. You just go ahead and say that, okay, I want to integrate this one. So you do have the option, you go to that wizard and you will just integrate the services. Now, SD-WAN deployment is immediately. So if you want to uh, provision the SD-WAN in your network, a new network, you can do it within 1 day itself. So it's not only 1 day, but you can do it within 1 hour. So once you have your controller up and running, then it's only the job for your edge devices to just to communicate with the controllers, and you are onboarded. And the main thing is that if you remember with the businesses, the main thing is the video quality and conferencing, because they do a lot of conferencing, they do a lot of meetings every day. Now, this is a big step because they have now overcome this problem. Now we do have a very good video quality, and conferences are very good now. So that was a basic of the Cisco SD-WAN, and next we will look at the more advanced features of the SD-WAN.